I'm going to really talk about kind of one big element of what we're doing, but also all the stuff that EWI gets into. Those of you know who EWI, I don't have any sales pitch slides, so I'll do it right now real fast. But we're process experts, right? Welding, materials joining, anything like that, that's what we do. And that's where we fall into the big piece. As things are starting to change, political climate's happening, we're starting to onshore stuff, that's got to be automated, right? So we're seeing that trend. I'm sure many of you are. So going to kind of dive into the stuff that we're working on. And so I call a lot of this stuff convergent manufacturing. You've probably seen that buzzword. I'll define it how EWI defines it, but you can call it whatever you want because everyone else does the same thing. So they released this workshop a long time ago with convergent manufacturing. It was a DoD type thing, an element that they went back and defined it as really converging the integration of physical components and digital components, right? So just like ROS does, you guys have a digital twin, you have a kinematic digital twin, you can take and represent and actually do toolpath planning, do process planning, all that kind of stuff in there. And so for us, that's where we see it is, it's not just the software side, it's software enabling hardware to do a process, right? For us, that's really important because at the end of the day, if you can't do a process the right way, you can't really automate it to begin with, right? And that includes everything from materials all the way to the final end robustness. And so we kind of define convergent processes in 3 different buckets for us. There's additive processes that can be anything from arc DED, laser DED, cold spray, thermal spray, using traditional power supplies, things that already exist. We have subtractive technology, so the stuff with push core that they just talked about, robotic torch cutting, anything like there that you're actually doing material removal. And then there's also transformative, heat treating is a thing, right? You do something, you mess up the microstructure, you got to go back and do the heat treat to fix it. And so all of these things are converging hardware processes with material properties with software tools that kind of define all of that. And so at EWI, we have lots of different robot systems. They're all off-the-shelf equipment, mostly, that we kind of use for this type of stuff. So this is our gantry system. I throw it up there because it's big and flashy and sexy. But it's got 2 different arc welding power supplies on it. We actually just integrated a 6 kilowatt laser into it as well that we're using for laser shot peening and also some laser DED applications. We've got a push core on there doing grinding, brushing, machining on this system as well, all within the same scope. We will be using 2 or 3 different commercially available software tools to help enable this, PowerMill, AdAxis, Siemens NX, all of that kind of stuff we kind of dabble in and play in just depending on what our clients need and commercial people need. With this, a lot of the stuff that we try to break it down into for convergent manufacturing is there's a physical system, there's manufacturing processes, and then there's also a workflow associated with those, right? It's if you go transformation matrices, which I'm sure a lot of you guys do, the order matters, right? You can't do certain processes, certain orders. There's joint limitations. There's all the things that go along with like being able to build stuff. And so my background's a lot in the arc DED side. So there's lots of complex toolpaths there. Max kind of mentioned it, right? You get a part out there, you got to do complex circles. Those circles have to be stacked on top of each other, 700 layers, and those all have to be controlled within a couple millimeters for your stick out and contact distance, such that you're getting good process settings. So there's a lot of nuance that goes into actually applying a process for robotic applications. So this is just an example of a part that we built. So custom ultra high strength steel that we worked with ESOB to actually develop the custom metal core consumable. We did the material property testing and then we're able to simulate it and put it in on one of our systems. So the big thing that I think a lot is overlooked in some of the applications is supporting processes, right? Hey, you got to have an IR camera on this to measure interpass, but sometimes those aren't accurate enough, right? So you need to get a laser pyrometer. You got to do torch maintenance. If you're those guys who've been in those heavy industries, you can only weld so long before you need to do a tip change, before you need to do stuff, right? And that's part of your system, right? It fundamentally has to be integrated into your system and into your workflow. People like to throw out lights out, right? That's another buzzword, right? Let's turn the lights off and let it get going. There's a lot of nuance for those people that try to run it. Gas management, being able to update your TCP on the fly, all of those little small things, right, that stack up and build that tech debt, right? And so that's where we feel we play a role in this, is trying to kind of help understand all of those for that convergent manufacturing workflow. And at the end of the day, it really boils down to those bottom 2, right? Ensure your process stability and recover and prevent errors, right? If you do those 2 things for your process, you get a good part out. So This is just an example. Throw it up here because I told Max I would show the push core a little bit. But this is just an example we did. We did a project with the Office of Naval Research using flux core DED. So for expeditionary environments, you don't want to carry shielding gas, right? So we're actually using a flux core electrode. If you guys know anything about welding, we go back, we brush off every layer. We're actually using a custom electrode as well as a special patented apparatus that we're reducing shielding gas down to 5 CFH for 316 stainless steel, still meeting nitrogen properties, still meeting all of the AWS spec requirements for that. With this, you got to go back and clean the slag off every pass, right? You got to go back, and then afterwards, what's nice is you can do this all in one system. You can go back and post-process the surface, as you can see on the right. So we're doing all of this with ATI tool changers, switching back and forth between those, using our trajectory planning software to actually drive the tool pass to what we need to, while also layering in all of that other stuff I talked about. IR control for interpass sensing, force control for the compliance device. There's a lot of different elements that kind of fall all the way out into this. And so just one of the many examples and one of the ones I can talk about. So this one's a little fun one. So I want to talk a little bit about data. That's kind of where I'm kind of going next with this. We have a really strong data science group here at EWI that's all focused on manufacturing data. And so we have a process. I got these slides approved last week, so that's always good. Working on maintenance, repair, and overhaul, right? So those of you guys know that for the DoD, this is a huge element, a huge area. There are so many depots all the way across the United States who are almost doing the same thing or so close to doing the same thing, just different materials, different, slightly different cell setups, different robot arms, different process heads. The geography, plays that divergent role. These guys don't talk to each other, right? And they have no idea sometimes what others are doing. Being able to transfer data and making it qualified, is kind of treated as tribal knowledge and secrets. And so it's something that's really important is how do we build the infrastructure around this that enables crosstalk, right? That enables transference of process parameters, that transfer of those manufacturing workflows across depots to build efficiency. And so this is something that I'm shamelessly stole most of these slides from Alex, but fair data, you guys know about this, I've heard this before. There's probably $17 billion a year in euros lost just because of how badly data is organized. Right? How often have you guys, your welders, gone back and been like, oh, we welded this 10 years ago with these settings, and you can't find them, right? You got to go talk to the guy who talked to somebody who, oh, I think it was close to this, right, and tune it back in. And so with a lot of this stuff, what we've tried to do is build a digital thread and an infrastructure that we can actually use and reuse, right, collecting the appropriate data and contextualizing it within the manufacturing processes as well. And, this is, I'll let you read this, but black boxes. Another huge issue, right? This is the one thing, vendor lock. You hear the DoD talk about it all the time. This is something that is a huge problem, right? They don't know how something works. We can't explain why it works. It just does, right? You get the same OEMs providing the same equipment over and over again because it's too much cost intensive for them to be able to redesign and re-implement something. And so this is something that I feel like as a community in manufacturing and robotics that we have to do better at, right? We have to be able to find ways to be able to cross-collaborate and talk about those. So getting into this. So this convergent digital infrastructure, we are about halfway through a 4 or 5 year project working on this. Really, it's pretty simple at the end of the day. It's an MQTT broker. We've kind of built our own edge of network drivers that are collecting all this data and contextualizing it. So it's meant to be kind of plug and play device integration. So this is part of why I'm throwing this out here in the ROS. I'm trying to figure out all the things that already exist. We don't want to reinvent the wheel here, right? A lot of this is just about how you organize the data that we're generating such that it can be reusable and interoperable. And so we are working across, kind of mentioned it before, laser DED, cold spray, thermal spray, arc welding, and then actually NDE processes and trying to use this similar infrastructure to do all of this stuff. The Fair Digital Thread, we tie that back into a MongoDB database, which is really just they actually use that, I believe, for the stock trading markets, right? So it's super stable. The code base is out there. You're really able to leverage all these things. We're using the ISA 88, which is a ontology that was built that you can basically categorize things by equipment, by process, and build, as Max kind of talked about, that recipe model, right? So we're starting from that sequence because at the end of the day, it's really about a recipe on how you make and create parts and how you do those processes. We have built what we call a recipe sequencer, right? And so this is all run off of a online tool that we're using that we can actually access all of those things from the edge of the network, run this all semi-remotely. Most of these are associated with teach pendant toolpaths that already exist, right? So we're pre-planning those, but those are associated with all of the process data behind it. But we have all of the functionality that you would normally have to be able to access and get into each of those, as well as the data recording right on top of it. Alex always says when he's trying to do data recording, it should be like breathing, right? You don't think about it, it's constantly happening, right? But if you can make data infrastructure and data recording part of just the built-in way that you attack things, you don't have to think about it, it's already there. Oh, why did that work and this one didn't? We can go back and cross-compare instantaneously and say, you're right, we had a velocity change. Why did that happen? Oh, a kinematic change, right? All of that stuff can be tied back. You see it in the process, you say, hey, it didn't work, but it's based off of a robot kinematic. Right? How do you correlate and crosstalk between those two? With those as well, we have built a lot of models. So again, we're process experts, right? These are pretty simple. They're just deposition models, right? I mean, it's nothing crazy, right? It's bead height, width, stepovers, right? And now we're starting to grow these and add to our, I'll say, repertoire, right? Different material types, different spray parameters, what that wide and width of those are and how we attack that. So the data flow example, again, just throwing this up here, we got equipment, you've got the communication codes, we run all of that through an MQTT broker. We're using Kafka and MongoDB to store in the database. We've got real-time displays, we've got recipe sequencers that we're using to tie all this together. And so again, this is the start, right? It's not 100% there, but from a data manufacturing standpoint, it's really important to understand all of the nuances that go into that. Okay. And then this is really just saying, hey, this all falls into that schema. So the beautiful thing about the ISA 88 is when we store these toolpaths, right, we can say, hey, we want to do the exact same spray again, but maybe apply it to a different toolpath geometry. And so it's all the stuff the welders have done before, right? Hey, we know how to weld this kind of thing. Let's replay that and redo it. Okay, so just going through some, so I was tasked to talk about challenges, right? So now we're kind of getting into the challenges. So I've kind of laid out the stuff we're working on, some of the things that I feel is important that we address and try to get through with this. Digital twins, another great buzzword, but there is a lot of differences between your CAD and whatever your simulation is, how people treat their joint kinematics between power supplies and robots. At the end of the day, a robot is a robot. It has a behavior and the controller goes in a direction you need it to, but it's just moving a TCP in space, right? So how can we come and make sure that I can pick up a Fanuc robot or a Yaskawa robot and use it for the same application? Those types of things are really important. Post-processor, maybe one day we'll get to the point where we don't have to run teach pendant codes for every little thing in a manufacturing environment, but I very much doubt that anytime soon. So we got to understand how you can cross-translate those as well and make sure that all of those supporting processes, IR, things like that, can actually be integrated the same way. So that's something that's really important and that I love about ROS is the fact that there's kind of already this built-in framework that we can leverage between those. And again, example workflows and current use cases, right? How can we learn from something that people have already done before so we don't have to completely reinvent the wheel to start over again? I throw this up here to say, you guys saw that demo up here. There's a lot of steps along the manufacturing process. Again, order matters, right? But at the end of the day, you kind of need a process expert. That's something I'm learning as more of a robot-centric person in a process-heavy organization, is that at the end of the day, we're slave to the processes, right? If you doesn't matter how well you can make the robot move, doesn't matter how awesome whatever sensor you have, if you put down bad material, you put down bad things, you go back and make something wrong, nobody cares, right? You could have the coolest thing on planet Earth when it comes to the toolpath planning, but nobody cares. You can't do it right. And so process stability and knowing the right way for manufacturing and workflows is very, very important. And then lastly, again, back to that cross-platform qualification and transference. I think this one's key out of everything that I talk about today. We talked about that divergence that happens within the depots themselves, right? How can I cross-qualify this type of thermal spray gun with the other one, right? How do I know that if I use a Fanuc motion controller or a Yaskawa motion controller, an ABB controller to do the same physical pass in the virtual space, that it's actually having a similar behavior? And this is something that we, as robot people, should have a little bit of an internal, we should turn and look inwards on this, right? And talk about better ways to figure this out, because when you're looking at thermal spray, it's velocity control, right? It's all about the speed at which you move, not necessarily the accuracy. You get into stuff like automated NDE, where you need to be triggering every 0.01 millimeters to be able to take that eddy current measurement, right? Two completely different things, but are enabled by the same exact mechanical architecture, right? And so it's really important to understand those nuances and differences and understand that, hey, we are a slave to the process, right? So we're gonna have to sort that out within ourselves. And yeah, so that's just concluding thoughts about a lot of that. Process stability, those manufacturing workflows, digital twins and cross inference, supporting processes and all that data. And so, we've got a lot to go out here and look into this, but I'm looking forward to getting integrated more with everybody.
Excellent. Thanks, Logan. So we have a couple minutes for questions for Logan. Logan, can you go back to the pictures of all the cells?
This one or this one?
No, this.
Yes.
So I mentioned earlier about a little bit of distinction, right? Like we can exchange information, right? We can talk about joint states, but this is definitely a little bit more in the weeds, right? Here I talked about the semantics. Like, so we had that big conversation. Dave Coleman raised it, and then we got on the global, and then we're talking about interoperability across controllers. You get we start talking about some of these like motion, right? Constant velocity, accurate path versus velocity trade-offs. All of these manipulators make those trade-offs different. And so long ago, I could pick up my FANUC or my ABB manual and maybe a Scala manual, right? And I could actually sit there and it would actually talk about like, hey, you turn this little knob and it's going to honor the path, right? Or you make this and it's going to more consistent velocity around the corner. That level of semantics is, I think we've lost a little bit of that, or it's hard to discern that even with able to move. And is that something I assume you've observed as well?
Oh yes, all the time. So yeah.
So I think as we begin this journey about rethinking some of our practices to help OEMs provide better interfaces, helping them think too a little bit about how that's why we use the term behavior quite a bit when we're talking about our process too, right? And it drives confidence in the end user, right? I want to make sure when I tell that robot to make that move, it's going to make a move that makes sense. To make a move that I would do with the teaching.
Yep.
Right. So consistent behavior, particularly as we hop from yellow to orange. I don't know if anyone else is here. Right? Raise a hand. Who's programmed a closed robot? Yeah, only a couple of us, right? Like at Steve, right? Yeah. So that was less fun to get autonomous motion control working on.
That's putting it lightly.
Anyways, but no, Logan, thank you for bringing this perspective. I think there's a big community out there interested in doing things like thermal and cold spray and welding, where this, say, deterministic behavior is very much of interest. And currently, right now, it's not really in scope, right? It hasn't been largely brought down to that detail in our. Any other questions for Logan before I just keep going on? Yes, Roger.
Hey, Logan, good presentation. When you build this aggregation of processes and process knowledge, and you pull in history, and you don't have to go ask somebody to find how they did that. How do you plan on democratizing that?
Sorry, the question was democratization of so to speak, this how you did it before, right? History.
Yep. I guess slight anecdote that I'll start with is one of my first projects at EWI when I got there was plasma DED, right? And I am not a welder. Well, I'm more of a welder now than I've ever been, but I was definitely not a welder when I showed up at EWI the first day. And I remember talking to Tim Moore, who's one of our best welders, been doing it for 30, 40 years. And he gets down there and I'm said, how do you know a plasma weld is good, right? As you're doing it. And he just goes, you just know, right? And I'm like, man, that's really helpful as an automation guy. How do I action this, right? And I think especially in the materials joining space, right? It's a in-product driven result, right? And so from that side and that perspective, democratizing it really starts with, can you do it right the first time, right? And so our plan is, it's one thing to build a data model. It's another thing for that data model to actually be useful, right? And actually have good data in it. So that's what we're starting with. That's kind of the base level. As far as how do we get it out and how do we push it? We are actively seeking collaborators for this. I'm hoping, and part of our kind of call with the AFRL as part of that MRO project is actually making all the depots work together and share and exchange that information, right? And so I don't know that we're going to make all of the data publicly available because you start getting into ITAR restrictions and all that kind of things. But I think there are opportunities. You see it across a lot of materials joining space where data sharing is starting to happen. And that's not necessarily for us to decide. But if you want to talk more about it, I'd love to talk about ways we can do that.
Yeah, if anyone who's like actually worked at a large company, like trying to get standard data practices across the whole corporation is like pushing the rope.